Hi AP Physics, Nicole here again, and this time we're going to be looking at the 2003 AP Physics B question number 5. This is a thermodynamics question. So first you can look at this graph. It's a PV graph showing the relationship between pressure and volume, and then we can read the question. So, a cylinder with a movable piston contains 0.1 mole of a monatomic ideal gas. The gas, initially at state A, can be taken through either of two cycles, ABCA or ABCDA, as shown by the PV diagram above. The following information is already known about the system. So, Q from C to A equals 685 joules along the curved path. So in this point, we're going to be looking from D to A to C and back to D. And then work from C to A is equal to negative 120 joules along the curved path. So the same path we just drew out before. UA minus UB equals 450 joules. So that's the change in internal energy. And work from A to B to C is equal to 75 joules. So part A asks us to determine the change in internal energy, UA minus UC, between states A and C. Pretty simple. Let's do that up here. Okay. So, in order to solve for the change in internal energy, we will use the formula delta U equals Q plus W. This is part A. And then just plug in what they gave us. Delta U equals Q, which they gave us is 685 joules. Now, the formula is plus, but if you look, it shows you that work is negative. So, minus 120 joules. And then when you solve everything out and plug it into your calculator, you'll get that the change in internal energy, or delta U, equals 565 joules. Very simple. A lot of these physics problems are very simple when you think about it. All it is understanding what formula to use and what to plug in. So that was part A. Now, part B is asking us, is heat added or removed from the gas when the gas is taking along path A, B, C? So, let's look at path A, B, C. So we're going from A, which is up here, B, which is down here, and then C. So, this shaded area. Is heat added or removed? Well, when you think about it, heat is going to be removed because there is a negative. Delta U is equal to negative 565 joules. Okay? So when you think about it, it's asking you to, again, calculate the amount added or removed. So we're going to prove this now. We have that delta U is equal to Q minus W, because we saw before that there is a negative work. So, if we're solving for Q, we get that Q equals delta U minus W. Then, just plug in what they gave us. Q equals negative 565 joules, which we just solved for in part A, minus 75 joules, which they gave us, and we get that Q equals negative 640 joules. So, we see that it is indeed negative, therefore heat is being removed from the gas. Then we go on to part C. Let's just get a nice blank space to do the same. Okay. Part C asks us, how much work is done on the gas in the process C to D to A? So basically what it's asking us to do is solve for the total work. So we have part C here. Work total is equal to the work of C to D plus the work of D to A. Okay? And then we know that the work from C to D, is equal to 0 because it is a vertical line. And when there's a vertical line, we know that there is no change in volume, therefore the work is 0 joules. And then we know that the work done from D to A is just equal to negative P delta V. Okay? And then we can plug in. Now, when we're doing this, we're going to be using the points on the graph to plug in. So, if you look along on your sheet of paper, you can get total work is equal to negative 6 times 10 to the 5th pascals, which is the pressure, times the change in volume. It was initially at 1 times 10 to the negative 3rd meters cubed, and then it goes to 0.75 times 10 to the 3rd meters cubed. So we're going to subtract those two values, and then get the total work to equal negative 150 joules. Okay, easy enough. And then finally, part D asks us, is heat added to or removed from the gas when the gas is taken along path C, D, A? So again, let's get a nice blank area on our paper. So evidently, the heat is going to be added. And this is pretty simple. All you have to know for part D is that since the delta U is positive, so we have a positive delta U, and there is a negative work because we solved for both of those, there also has to be a positive Q. So therefore, there's going to be a positive Q. And since Q is positive, that means that we are adding heat to the system. Okay, hope this was helpful. Again, this was 2003, question number 5. If you have any more questions, feel free to ask me.